Assalamualaikum warahmatullahi wabarakatuh. First of all, my name is Muhammad Hafiz bin Abdul Rahim. I'm from BMMP Section 2. My supervisor name is TS Dr. Hanizam bin Hashim. So the topic for my project is a newly spiral channel mechanism to produce non-dendritic grain microstructure of aluminum alloy for semi-solid processing. Okay, let's start with the introduction first. Casting is the one of the manufacturing method. It can give a lot of benefit. So this method become popular because their mechanical properties. So aluminum alloy is used for automotive industry fabrication. The type of aluminum that I use for my project is A35. So when the solidification is complete, the dendritic form happen when a crystallized edge or corner is selected for the development. So this development of microstructure is look like a tree shape. So many engineer and researcher uh, try to convert this dendritic form into non-dendritic form in many years. For semi-solid metal processing, it can separate with two categories. So either to liquid or solid state. Okay, after I'm doing my literature review research, what I found is cooling slope is the one of mechanism that to change the grain microstructure dendritic into non-dendritic form. So the problem for this method, it cannot perform or apply at all application. This is because it difficult of controlling the process and air entrapment. Second, the parameter and angle is the important key that affect the microstructure directly. So to perform or to run this experiment, water cooler is needed, so it can give a costing for the maintenance. We moving to the objective of this project. Okay, point number one, to fabricate a new design spiral channel. And second, to compare the spherical factor or the roundness of the microstructure between spiral channel process and direct casting. And lastly, to analyze microstructure data using t-test analysis method. Now we move the scope of research. In this final year project, this experiment will be conducted at FTK lab. So we will focus on the design concept of spiral channel. This spiral channel is made from my steel. The material that we use for casting is aluminum alloy with code A356. So this A356 is heated using a furnace until it reaches the temperature of 700 Celsius. So the pouring angle is 90 degree before enter the single cavity mold. So after we get the product one, we need to prepare to do metallographic procedure. So all the specimen need to examine using optical microscopy. So the data that we get, we need to construct the t-test analysis and using Minitab software. Okay, now let's focus the literature review for this project. Permanent mold casting is widely used for complex shape. Usually, it makes from metal. It consisting of two or more parts. It also can repeatedly used for the production. In permanent mold casting, molten metal flow into the mold by gravity. Non-ferrous metal are used in this process, such as aluminum alloy, magnesium alloy. Type of casting is produced automotive part. It's like wheels, piston, bracket, and many others. Grain microstructure dendritic form. When the alloy solidification, most common structure seen is a dendritic structure. Most complex pattern that develop is from dynamical growth process. It is important to know the dimension parameter in solidification uh, based on the microstructural length scale. Depends on the method. Okay, now what is semi-solid metal processing? It's discovered and developed at MIT. SSM technology are divided into two categories, either from liquid alloy through the controlled solidification under specific condition, or from the solid state through the heavy plastic deformation and recrystallization. Casting and forming operations are used in this manufacturing technique, regarded as economical, high productivity process for manufacturing many type of metal part. This is used with non-ferrous metal such as magnesium, aluminum, or copper. So this semi-solid metal processing is near to net shape. In recent years, the engineer and the researcher has discovered the way how to change the grain microstructure dendritic into the non-dendritic form. So this is the mechanism of the non-dendritic: magneto-hydrodynamic steering, cooling slope, and mechanical steering. Okay, let's go for the technique number one, which is magneto-hydrodynamic steering. For the past 20 years, this method already patented by Alumux and mostly widely used for this method process. Vigorous steering by rotating magnetic field within the mold, normally for producing feedstock for tissue casting. This integrates fine dendritic, which convert to globular grain on partial melting. So this method have too many steps and can cause the costing. Second mechanism to change the dendritic into non-dendritic is cooling slope. It is simple non-agitation process by applying a low superheat. The length and angle is the important key for the parameter to conduct this experiment. And the problem for this method is it's tough to keep on track when we do a pouring process before enter the mold. The mechanical steering technique is developed at MIT for reo casting and tissue casting. This method is steering of the liquid alloy while control cooling in semi-solid range using impeller or pedal. For this technique, it can cause the risk of gas interruption and the oxidation by the steering process. Okay, now let's focus on methodology of spiral channel to produce the grain microstructure non-dendritic. First, I started to create two design concepts using CATIA and SolidWorks software. After I analyze the drawing and discuss with my supervisor, the second drawing is chosen to fabricate this spiral channel. The material that I select for this spiral channel is my steel sheet. To cut the material, I use the abrasive waterjet machine and turning leg machine as my operation to get the spiral channel. For the casing, it also same material, which is sheet, my steel sheet. So I cut this material using shearing cutting machine to get the precise dimension. I use a hand notcher, and for making the shape of the casing, I use roll machine. And lastly, to assemble all the part, I joining by welding, which is MIG. So after it's done, the spiral channel need to do a rub process to remove rust by sandpaper with different grit. And lastly, the spiral channel spray with the black color to look net. Okay, for the casting process, we prepare the equipment first, such as furnace, single cavity mold, and the material need to cut first for easier melt. The aluminum alloy is heated using the furnace until reach the temperature of 700 Celsius. Then the molten metal pouring into the mold with 90 degree using spiral channel. After the solidification is complete, remove the product bond and repeat this operation again without spiral channel. So the product bond need to prepare the metallographic procedure. For sectioning process, the product bond need to divide into 10 specimen with dimension 10 mm. And for the next process is grinding process. This process need to do a proper step by step using sandpaper with different grit. And for the next process is polishing. So this operation I use 6, 3 and 1 micron with diamond paste. And lastly, etching process I use eye solution color for 3 or 4 seconds. So all specimen must be kept safe and clean and dry. For examine the specimen, I use the optical microscopy to with the eye solution DT program to observe the microstructure grain. So all the data need to save the Excel and prepare to do t-test analysis. We moving forward to the result and discussion. Okay, based on these two design concepts that I create using CATIA and SolidWorks software, the second design is selected to produce the spiral channels. This is because the second design have a better illumination compared to the first design, which is 320 mm. So the reason because the pathway for the molten metal before the entering the mold, it can cut off more the dendritic arm. So That is why the second design is better than first one. Okay, for this slide, I will talk about the comparison grain microstructure between spiral channel and direct casting. As you can see, this picture already taken from optical microscopy with iSolution DT software. For specimen spiral channel that we observe, it shows the grain microstructure near to globula. This is can prove by the average of roundness is 0.493 compared to the direct casting specimen, which is 0.3632. So by the facts, it can prove the spiral channel mechanism can produce the grain microstructure non-dendritic with good quality. Okay, this slide shows the t-test analysis data. Before I go to all the specimen need to do optical microscopy. For one specimen, collect the 30 data. So all the data for spiral channel is 150. Same with the direct casting. This is because to get a normal distribution. So based on the blocks plot, you can see the data for spiral channel and direct casting is significant. This is proved by the p-value that Minitab calculate. It get 0.000 below than the confidence level, which is 95%. Effect non-dendritic for semi-solid metal processing. The SSM is processed at the lower temperature. This can eliminate the air entrapment and reduce the shrinkage. The mechanical properties of the grain microstructure are changed depends on the technique or the method applied. To conclude that, after doing discussion and analyze, the spiral channel has been produced well according to the drawing detail. The spiral channel technique proven the grain size microstructure to get a near globula after observed using the optical microscopy. The roundness of spiral channel achieved higher than direct casting. This can be proved from the t-test that the average from the spiral channel is higher than the direct casting. That's all from me. I hope you can understand well the explanation that I give. Thank you.